All right, we're continuing with this section 5 on part 1. So there's a lot of exercises to do for this part. I think there's 1, 2, 3, 4, 5, 6 exercises. So, and then there's a survey at the end. So I'm just going to do the first 3 after the reading. So we'll do this one, the calculator, the temperatures, and the daily wages, and then we'll do a separate video covering the remaining 3 exercises. So before you watch this video when I do the exercises, if you want, you can go ahead and try them out yourself, see what you come up with, and then come back and finish watching this video. But if you just want to follow along, I encourage you to do that as well. So either option is perfectly fine. All right, so we're continuing to learn about Boolean values and Boolean expressions. It says any condition used in a conditional statement will result in a truth value, that is, either true or false. For example, the condition A is less than 5 is true if A is less than 5, and false if A is equal to or greater than 5. These types of values are often called Boolean values, named after the English mathematician George Boole. In Python, they are handled by the bool data type. Variables of type bool can only have 2 values, true or false. Any bit of code that results in a Boolean value is called a Boolean expression. For example, the condition in a conditional statement is always a Boolean expression, and the words condition and Boolean expression can often be used interchangeably. The result of a Boolean expression can be stored in a variable just like the result of any numerical calculation. So here we have, in this program, we have a variable a called equal, which is assigned the value of 3. Then we have a variable called condition, which stores the result of the evaluation of a and 5. So it's going to check if a is less than 5, and in this case a is 3, so is 3 less than 5, and that's true. Then we print the condition, and we check with a if statement. If that condition is true, then we print a is less than 5. So again, if we run through it, what's gonna be printed out is true, because when we print the condition, because remember, Boolean expressions always evaluate to true or false. In this instance, a, which is equal to 3, is less than 5. So this becomes this condition variable points to the Boolean value true, and so we print true, which is this line, and then we evaluate if condition. Again, basically saying if true, then do this. In other words, it's like saying if a is less than 5, print this. So this is kind of doing the same thing here. I mean, it's like replacing this step from being evaluated in the header of the if statement. The Python keywords true and false can also be used directly. In the following example, the print command is executed every time because the value of the condition is true. So we have a variable here called condition, and it holds the value true, the Boolean value true, and we just ask, if condition, then do this. So basically, if true, then do this. So this is going to work every time because this is true. Condition holds the true Boolean value. So this is printed every time. In the future, when we go through loops, which I think will be in part 2, conditions will be really, really important because that's what enables us to do loops and other types of high-level functionality in programming. But let me not get ahead of myself. A program like this is not very useful, but later on during the course, you will see examples of Boolean variables coming in very handy, which is what I was just talking about. Okay, we have our first exercise here called calculator. It says, please write a program which asks the user for 2 numbers and an operation. If the operation is add, multiply, or subtract, the program should calculate and print out the result of the operation with the given numbers. If the user types in anything else, the program should print out nothing. So this is our expected behavior with examples. So the first number, we plug in 10, second number, we plug in 17, and then we provide addition as the operation. So the program is going to do 10 plus 17 equals 27. And here it is with multiplication. We plug in 4, we plug in 6. We provide the operation as multiplication, and the program is going to print out 4 times 6 and the result. And here's same thing with subtraction. We plug in 4, we plug in 6. We provide the operation of subtraction. program is going to print out 4 minus 6 and the result of that operation. So this is fairly straightforward. We're just going to have two variables, one called number1, which is going to hold an integer, which is typecasted from the user inputted value, like that. And then we're gonna duplicate that line. Now I've been doing this a lot in some of the exercises, and I don't know if I've explained this, but if you do Shift Alt in the down keyboard, it will duplicate whatever line the cursor is hovered over. So instead of having to manually do something like this, number2 is equal to blah, 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 and you just want to fast forward a little bit, if you hold on the Shift key, the Alt key, and the down arrow key on your keyboard, it's going to duplicate that line that the cursor is currently hovered over. So it's a neat trick. And if you want to delete the line without having to hold down the backspace, if you hold Control, Shift, and K on the keyboard, it's going to delete that line that the cursor is currently focused on. All right, so that's another keyboard shortcut that you guys learned so far. So we're just going to change that to number2, change that to number2 as well. Then we're going to have a variable called operation, which is going to store a string user inputted value, like that. And then we're just going to print out, we're just going to do three things. Because we only have to worry about subtraction, multiplication, and addition, we can just have if statements that specifically check for those three. So we can say if operation is equal to add, then we're just going to do printf, then we're going to do number1 plus number2 is equal to number1 plus number2. Then we're just going to copy that. Again, Shift Alt down arrow key. Going to change that to subtract. Then just change the symbols here. And then do the same thing for multiplication. Now we're not told to worry about spelling in this instance, but if you are building a more comprehensive program and you will have to, take into account spelling, whether it's shorthand or whether you're using capital letters and whatnot. So normally what you will do is whatever string input is coming in, is being stored, you would just automatically convert it down to lowercase. That's one way. So now whenever people type in, whether it's uppercase or you're doing some wonky casing in whatever operation word that you're typing in, it will just all be lowercase anyways. But we're not worried about that right now. So we'll just test this out before we submit for tests. So number one, what's the example they gave us? 4 and 6. So number one will be 4, number 2 will be 6. Then we're going to do add, and it does 4 plus 6 is equal to 10. And if we do 4, 6, and do multiply, it should return 24. So let's run some tests. Okay, so we got a problem here. And, right, so we have an error here. Your program does not print out anything with inputs 2, 1, subtract. Let's see. If operation equals, it's a spelling error. Subtract, not subtract. Let's test again, see if we get any errors. And we're okay. Awesome. We can also view the model solution as we always do. And yep, they did the exact same thing. Number one, we're able to track the first number, the second number, and the operation. Then we check if the operation is addition. We do that. If the operation is subtraction, we print out and do the operation inline to the print statement, and same thing for multiply. All right. Here we have an exercise called called temperatures, and we're instructed to please write a program which asks the user for a temperature in degrees Fahrenheit, and then prints out the same in degrees Celsius. If the converted temperature falls below 0 degrees Celsius, the program should also print out, brr, it's cold in here. The formula for converting degrees Fahrenheit to degrees Celsius can be found easily by any search engine of your choice. And then 2 examples of the expected behavior. So if we provide 101 degrees Fahrenheit, it's going to print out 101 degrees Fahrenheit equals to 38.333336 degrees Celsius. And then if we do 21 degrees Fahrenheit, it's going to do the conversion result and also print out brr, it's cold in here. All right. So we're going to need two variables, I think, one to track the degrees Fahrenheit and one to store the converted degrees in Celsius. So we're going to have degrees F, which equals to an integer with the casted user inputted value. So we're going to ask, please type in a temperature Fahrenheit. Then we're going to have a variable called degrees C for Celsius. And to convert from Fahrenheit to Celsius, the formula is the degrees Fahrenheit minus 32 times 5 divided by 9. And then what we're going to do is just write, print out using an F string. We're going to do degrees F Fahrenheit equals, it's going to do degrees C degrees Celsius. So let's just test this out to see if I remember this formula correctly. I think I did. So let's try with 101. Okay, that worked. And let's try with 26. Okay, that's not right. I'm sorry, not 26, 21 degrees. So that should be right. 21, yep, negative 6.11111. So the last thing we need to do is just check that if the degrees Celsius is below 0 to print out this final line here, brr, it's cold in here. So for that, we're just going to do if degrees C is less than 0, then print that. So now, if we run it again and we do 101, we get that. And if we do 21, we get this. So let's run our test here, see how we did. And we passed. Awesome. So see the solution. And they did the same thing. They did temperature F for temperature Fahrenheit. Then that's the user inputted value. Then they converted the Fahrenheit temperature in Fahrenheit to Celsius. So same formula, temperature minus 30, the Fahrenheit minus 32 times 5/9. Or you can do it the way I did, temperature Fahrenheit minus 32 times 5 and then divide everything by 9. It's the same thing. And then here they printed out the degrees, the temperature in Fahrenheit equals to this in Celsius, and then checked if it's below 0 in Celsius to print that line out. Awesome. And now we have this exercise called daily wages. And we're instructed to please write a program which asks for the hourly wage, hours worked, and the day of the week. The program should then print out the daily wages, which equal hourly wage multiplied by hours worked, except on Sundays when the hourly wage is doubled. So here's a sample output. If our hourly wage is 8.5 and we work 3 hours, and the day of the week is Monday, then the daily wage is calculated as 25.5 euros. And then here we have hourly wages worked is 12 and a half. Hours worked is 10, and the day of the week is Sunday, then we get 250 because now the hourly wage becomes 25 instead of 12.5. So we're going to have a variable here for hourly wage, which equals to a float because wages can have decimals. Then we're going to have a variable to track hours worked, which is just an integer value. Hours worked. And then we're going to have a variable for day of the week, which is just a string. Then we're going to do our calculations based on whether or not it's Sunday or not. So we're going to say if day of the week is not Sunday, then we're going to print daily wages as hourly wage times hours worked. And if it is Sunday, equals Sunday, pardon me, then we're going to print daily wages is equal to hourly wage times 2 times hours worked. In fact, you can probably do this, have a variable here called daily wage, set it equal to 0, then inside of here, do daily wage is equal to hourly wage times times hours worked. Actually, we just have it here as hourly worked times, pardon me, hourly wage times hours worked. And then, if it's not Sunday, just print it as daily wage, euros. And if it is Sunday, then just do daily wage times 2. Like that. I think this should work. Euros. So let's try it. So we'll do the 8.53 on a Monday. See what we get. So hourly wage is 8.5. Hours worked is 3. Day of the week is Monday. And we get 25.5 euros. Awesome. Let's do it 8.53 on a Thursday. Again. And then let's do 12.5 for 10 hours, and day of the week is Sunday. We get 250. Let's do the same thing, 8.5, work 3 hours, and it's Sunday. All right, awesome. I think that should work and pass all our tests. Let's see how we do. And yes, we do. And as per ritual, we test the model solution. Okay, so this is even a very clever solution, just using the shorthand annotation here. So they have 3 variables like we do to track the hourly wage, hours worked, and what type of day of the week it is. And then they check this condition that if weekday equals Sunday, then just do the hourly wage times 2. And then they print total wages equal to hourly wage times hours worked. Then print daily wages is total wage in euros. So this is actually a very sleek solution. Much less, not as extensive as ours. But yeah, you can do this, which I really like. Very sleek. Or you can just do this for a little bit more clarity. So we just calculate the daily wage, which is hourly wage times hours worked. And then we print if it's not Sunday, print that. And if it is Sunday, then print that. All right, cool. So that's just going to be that. Those 3 exercises we just did in this video. In the next video, we will do the following 3 exercises for loyalty bonus, what to wear tomorrow, and solving a quadratic equation. If you are antsy, you can try them out on your own and then come back to my video and watch that and see how we compare notes. But other than that, thank you so much for watching, and I'll see you guys in the next video.